Hello friends. Have you ever opened too many tabs in Chrome, started a video on YouTube, kept Word and Excel running in the background, and suddenly your computer slows down to a crawl? That's your RAM running out of space. But here's the interesting part. Your computer doesn't just crash or stop working. It keeps going. Why? Because of something called virtual memory. In this video, let's understand what virtual memory really is, how it works behind the scenes, and why it's the reason you can run 20 things at once even when your RAM technically can't handle them. Let's get into it. Alright, before we talk about virtual memory, let's quickly revisit what RAM actually does. RAM, or random access memory, is where your computer keeps everything it's currently working on. Every app you open, every tab in your browser, every file you're editing, it all sits in RAM while it's active. Think of RAM like your physical desk. You pull out the books and notebooks you need right now, spread them on the desk, and work on them. The desk is fast to reach, but it can only hold so much. RAM works exactly the same way. Super fast, but limited in size. Most laptops today come with 8, 16, or maybe 32 gigabytes of RAM. Sounds like a lot, but modern apps are hungry. So what happens when the desk gets full? Let's see. Now here's the problem. Your RAM has a fixed size. So what happens when you keep opening more apps, and the RAM is already full? In a world without virtual memory, your computer would simply crash, or refuse to open the next app, or throw an out-of-memory error. Game over. But that's not what actually happens, right? You can keep opening tab after tab, app after app, and your computer just keeps going. It might slow down, but it doesn't die. That's because operating systems, Windows, macOS, Linux, all use a clever trick to extend your RAM beyond its physical limit. And that trick is virtual memory. Let me show you the core idea. Here's the core idea. Virtual memory is a way for your operating system to fool your programs. Every program running on your computer thinks it has access to a huge, continuous block of memory, way more than your actual RAM. But that's an illusion. Behind the scenes, the OS is quietly splitting that memory between two places. The stuff you're actively using stays in real RAM, where it's fast. The stuff you haven't touched in a while gets moved to your hard drive or SSD into a special area called the page file or swap space. So from the program's point of view, it has all the memory it needs. From the hardware's point of view, RAM never overflows. The OS is the magician in the middle, juggling things back and forth. Let's look at where this magic actually lives on your disk. So where does this overflow actually live? On your hard drive or SSD, your operating system reserves a special area just for this purpose. On Windows, it's a hidden file called pagefile.sys. On Linux, it's usually a separate swap partition, or a swap file. On macOS, it's a set of swap files the system creates as needed. Whatever the name, the job is the same. It acts as an extension of your RAM. When your physical RAM gets full, the OS picks data that hasn't been used recently and moves it here, to free up space in RAM for whatever you're actively doing. Think of it like this. If RAM is your desk, the page file is the drawer underneath. You can still get to your stuff, but you have to open the drawer first. Now let's see how this back and forth actually works. The OS doesn't move entire programs around. That would be way too slow. Instead, it breaks memory into small, fixed-size chunks called pages. A page is usually around 4 kilobytes in size. So when your RAM gets tight, the OS doesn't ask, which program should I move? It asks, which pages haven't been used in a while? Those cold pages get written out to the page file on disk. That's called swapping out. And when your program suddenly needs one of those pages back, the OS reads it from disk and brings it back into RAM. That's swapping in. To make room, it might have to swap something else out first. This back and forth is called paging, and it happens constantly, in the background, while you're working. You don't see it, you don't feel it, most of the time. But sometimes you do, and that brings us to the dark side of virtual memory. Here's the catch. Your disk, even a fast SSD, is dramatically slower than RAM. RAM responds in nanoseconds. A typical SSD responds in microseconds. That's roughly 100,000 times slower. A hard drive is even worse. So every time the OS has to swap a page in or out, you pay a small speed tax. Usually that's fine, you don't notice it. But when you open way too many apps and your RAM is severely overloaded, the OS starts swapping pages in and out constantly, over and over, with barely any real work getting done in between. This is called thrashing. The CPU is busy, the disk is busy, but your apps feel frozen. Your mouse lags. A click takes 5 seconds to register. That's not your computer being old or broken. That's thrashing. The fix is usually simple. Close some apps, or add more RAM. So virtual memory is powerful, but it's not free. Let's look at the trade-off. So here's the deal. Virtual memory gives you more capacity. You can run more programs than your RAM physically allows, but you pay for it in speed, because the disk is slower than RAM. Most of the time, this is a brilliant trade. You'd much rather have your computer keep running and slow down a little then have it crash every time you open one extra tab. And modern operating systems are smart about it. They only swap when they have to, and they try to keep the pages you're actually using in real RAM. This is the same kind of logic Photoshop uses when you open a huge image file. If the image is bigger than your RAM, Photoshop creates its own scratch disk on your hard drive and pages parts of the image in and out as you scroll and zoom. Same idea. Trade a bit of speed to handle something bigger than memory can hold. That's virtual memory in a nutshell. Quick recap before we wrap up. RAM is your computer's fast workspace, but it's limited. The disk extends RAM through a special area called the page file or swap space, and the operating system quietly swaps pages of memory back and forth between RAM and disk, so your programs always feel like they have enough room to breathe. That's the magic that lets you keep 20 tabs open, music playing, a video rendering, and your code editor running, all at once, even on a modest machine. If this video helped you finally understand virtual memory, hit the like button and subscribe to Webronaq for more clear, no-nonsense explanations of how computers actually work behind the scenes. Thanks for watching, and I'll see you in the next one.